Kirchhoff's voltage law is also called Kirchhoff's second law or Kirchhoff's loop, and Kirchhoff's second rule. The direct sum of electrical potential differences or voltage around any closed network is zero. Or more simply, the sum of electromotive forces in any closed loop is equivalent to the sum of potential drops in that loop, or the algebraic sum of products of the resistances of the conductor and the current in them in a closed loop is equal to the total electromotive force available in that loop. It can be stated as the sum of all voltages inside a loop is equal to inside a closed loop in a circuit is equal to zero. Here, the N is the total number of voltages measured. The voltages may also be complex. This law is based on the conservation of energy, whereby voltage is defined as the energy per unit charge. The total amount of energy gained per unit charge must be equal to the amount of energy lost per unit charge, as energy and charge are both conserved. Kirchhoff's second law is also known as Kirchhoff's first law, or the Kirchhoff's point rule, or Kirchhoff's junction rule. The principle of conservation of electric charge implies that at any node or junction, the sum of currents flowing into that node is equivalent to the sum of currents flowing out of that node, or equivalently, the algebraic sum of currents in a network of conductors meeting at the point is zero. On this example, we can see that the current entering this junction are the currents I3 and I2, and the currents flowing out of the junction are I1 and I4. So the relationship using Kirchhoff's current law is the I2 plus the I3 is equal to the sum of currents I1 and I4. Similar to the Kirchhoff's voltage rule, it can be stated as sum of all the currents in a junction is equal to zero. N is the total number of branches with currents flowing towards or away from the node. This formula is also valid for complex currents. This law is based on the conservation of charge, whereby the charge, measured in coulombs, is the product of current in amperes and the time in seconds.